Today we're going to talk about section 4.1, increasing and decreasing functions. We're going to talk about finding intervals where functions are increasing or decreasing. We're going to talk about identifying one-to-one functions and identifying monotonic functions. The first thing we're going to cover is some interval notation. You've probably seen this before, but when you have a number line, say this is -1, 0, 3. If we want an interval that goes from -1 to 3 and includes both endpoints, we color in dots on those and color in the section. And the way we would write that is -1 is less than or equal to x is less than or equal to 3. Some interval notation, though, we would use a bracket to say that it's equal to this endpoint, -1, and another bracket to say that it's equal to this other endpoint at 3. We don't always have intervals where it's equal to the endpoints. We've done this sometimes when we've worked with other functions, when we've been graphing piecewise functions or something. We have open circles to show that it's not equal to that part there. If we want just this interval between 0 and 2, we would say 0 is less than x is less than 2, and not use those equal signs. The way we use interval notation for that is instead of the brackets, we use parentheses. So the parentheses means it's not equal to those endpoints, where the bracket means it is equal to. You could have it where one end is equal to and the other end isn't. For example, if this is 1 and this is 5, and we have an open circle here but a closed circle here on 5, and we want the whole interval in between, we would say 1 is less than x is less than or equal to 5. 5, we've got the closed circle, so it's equal to. And we would use a parentheses with our 1, but because the 5 is equal to, we would use a bracket. So make sure you know this notation. The bracket is used when we have an equal sign, and the parentheses when it's not. And you can have one bracket and one parentheses, or you can have a pair of each. Now, when you have functions, we talked about how sometimes a function is all over the place, but it's still a function because it passes a vertical line test. We have another specific type of function. It's said to be 1-to-1 because it passes a horizontal line test. If we have a function like this, for example, if we draw a horizontal line through it, it only crosses the function one time. What this means is every x value only has one function value. So every x value only has one function value. It passes a horizontal line test. This section's a lot of definitions, so we're just going to cover those really quick here. First thing we want to know is if a function is increasing. An increasing function, it means that as the x values increase, the function values increase. We can also have, so this would be an increasing function if we had one like this. We can also have a decreasing function, which is just like it sounds. It means that as the x values increase, the function values decrease. So if we have a function like that, it would be decreasing the whole time. If a function is increasing or decreasing all the way for its whole range and its whole domain, it's called strictly monotonic. So an increasing function is strictly monotonic, and a decreasing function is strictly monotonic. Now, sometimes it's not strictly monotonic. It doesn't stay the same the whole time. Sometimes we have a function and it is simply non-decreasing. A non-decreasing function means that it's either increasing or it's a constant. So we could have one that looks like this, where it increases and then it's constant and then it increases some more. We could also have a non-increasing function where it's either decreasing or it's constant. So it would be one that goes down and then is constant and then down some more. That would be non-increasing. These are called monotonic, but they're not strictly monotonic. So strictly monotonic would be just increasing or just decreasing. Just monotonic would be non-decreasing or non-increasing. All right, so there's all our definitions. So let's see if we can look at some examples here. If we have a function, f of x is 1/3 x cubed plus 2x squared plus 4x plus 1. If we graph this, it looks something like this. So we look at this function and we ask ourselves to describe it as specifically as possible. Okay, this function is increasing because as the x values get bigger, so do the function values. There's no constant place in it. It's always going up. It's an increasing function. We also can say that this function is 1-to-1. We look at if we put some horizontal lines in here, we're never going to cross the function more than one time. So it's 1-to-1. Every x value has a unique function value. Now, let's try another one. What if we have f of x is 1/x minus 3? Well, again, let's look at the graph. We know from our rational function studies that we're going to have a vertical asymptote at x equals 3 because that'll make the function undefined. The picture then is going to look something like this. So once we have this picture, we can look at it and say, well, it's decreasing on each of the parts, but it's not decreasing over the whole thing. We have to specify which intervals it's decreasing. It's decreasing from the far left, which is negative infinity. Since we can't ever equal negative infinity, we're just going to use a parenthesis. It decreases all the way till we get to 3, but we're not equal to 3, so we just put our parenthesis there. And, so we're going to use our union symbol. If we start on the other side of 3 and go on to infinity, it's also decreasing. So from here, it's decreasing, 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 and then it starts here again and decreases, decreases, decreases. This function is also 1-to-1. There are no x values that have more than one function value. It passes the horizontal line test. Let's try a piecewise function. If you remember, a piecewise function is defined in pieces. So let's say this one is x minus 2 if our x is less than or equal to 3. It's 1 if our x is between 3 and 6. And it's 1/2 x minus 2 if our x is greater than or equal to 6. So if we draw in our graph here, and let's see, let's do a red one. For the first line here, we have x is at -2, and then it goes up 1 and over 1, up 1 and over 1, and so on. So we have this line. This is our top part. But we only want from x equals 3, and everything's smaller than that. So we don't need all this piece up here. So let's get rid of that. Then we have this middle part. And middle part is this line. Remember, a number is just a horizontal line. So we have this horizontal line here, but we only want the pieces from 3 to 6. So everywhere else, we don't need that anymore. And then lastly, we have this line here, 1/2 x minus 2. So again, we're on -2, but this time we're going up 1 and over 2, up 1 and over 2, up 1 and over 2. So we draw in our line here for this last part, except we only want for greater than or equal to 6. So all this part that's less than that, we don't need. So here's our graph. So what does that mean? Well, is it increasing, decreasing, non-decreasing, non-increasing? Well, this function is non-decreasing because we have a part that's increasing and then a constant and then another part that's increasing. So we can say it's increasing from -infinity to 3, and since that part has the equals on it, we get a bracket on that. It's constant from 3 to 6. Neither one of those have an equal sign on them, so we use our parentheses. And then it's increasing again from 6 to infinity. This function is not one-to-one because we have a horizontal line problem here. If we pass a horizontal line through here, we're going to hit a whole bunch of points. So we have x values that all have the same function value. So it's not one-to-one. So this gives us an idea of how to describe these functions, whether they're non-decreasing, so that means this one's monotonic, increasing, constant, whether they're decreasing, non-increasing, all of those definitions gives us ways to describe these functions. Make sure you've read section 4.1 and you've looked at all the definitions in the yellow section and that you have some good notes for this section because they'll be checked tomorrow.